Well, in this week's WeatherWise segment, we're going to be talking about winds and why they blow the way they do. Well, let's first off imagine that we've got a balloon and it's blown up. Well, inside that balloon, it's much higher pressure than the air outside of it. That's why the balloon expands. Now, if we let the air out of that balloon, it's going to travel from high pressure inside the balloon to low pressure for everywhere else outside that. So you can say that wind blows from high pressure to low pressure. Now, this would be very consistent, of course, because with high pressure systems, we're dealing with cooler air. That cool air goes down to the surface and then pushes out to the low pressure, where that's more of a warmer system. That air is then going to rise, and it's actually going to become a circulation in the atmosphere. So we're going to be traveling from high to low. Now, it would travel in a straight line if we were a flat Earth and weren't spinning, but because we spin, we've got the Coriolis force. That means the winds are going to turn as they move. For a low-pressure system in the northern hemisphere, it spins in a counterclockwise motion, but for the southern hemisphere, that'd be the exact opposite, spinning in a clockwise motion. Now, it also depends on how close the systems are. If high pressure and low pressure are very close and there's a big difference between them, well, we're going to be seeing, there's a large difference. We're going to see the winds blowing a bit slower. But the closer they are, the bigger the gradient between them, the stronger the winds will be blowing. So, as we summarize, it's going to be blowing from high to low. Winds curve due to the Coriolis force, and the closer the systems are, the stronger the winds will be.